back to the second part of text normalization, in which we'll be covering the rest of the functions that we left in the previous video. In the previous video, what we did was we just created these basic functionalities. Where we could just apply the conditions on the arguments being passed, and the idea was simple. We wanted to have a function like this, normalized, and we could have just passed an argument and apply all the different sets of operations on our text and finally return the text, right? So that's what we have done in our previous video. Now we'll be implementing all these functions one by one in this particular video. Okay, so starting with the first function, which is the case convert here, which looks pretty simple and straightforward, right? We just want to be able to convert our case into upper or lower case, right? It's simple. So the condition that I have specified is that if we pass in the upper equals true, I should be able to just check if upper, okay, and if that is the case, then I should be able to return text dot upper. All right, and then else if no condition is passed, and if it's actually if you specifically explicitly specify this to be a false, it should return a text dot lower, right? And that would be our original text. Okay, so this looks good. So now if I just run this, I think it's taking its time to actually run things. Okay, I think the notebook is initializing, so let's just wait for it to run. First of all, okay, it ran. That's good. All right, and I think I should just make sure that my library is actually imported properly. So what I'll do here is okay, that there's a mistake here. Okay. Okay, so we don't have a library named Contractions, and I think that the reason for that is because this doesn't remember the library that I installed earlier. So what I'll do is I'll just go ahead and say pip install contractions. Okay, and then also right after I download NLTK, I should be able to specify as NLTK.download, because I know this must have not remembered the libraries and the packages that I've installed, because this notebook refreshes and I've not saved it, right? So we have to download everything again. So what we can do is we can just quickly run these commands and then install the libraries and then import the libraries. Okay, so let's see what happens. Now it's going to take some time to actually do the thing, so we'll just wait. Alright, so we were able to successfully run these commands, and now our packages are properly imported into our environment. So it's time so we now test the function out, which is the case convert function. So what I'll do is I will just call this function. I'm just gonna go ahead and just comment this out for now. And what I'll do is I'll copy the same text because I want to use the same text, and then I'll just say tn dot case convert. Okay, I'm just gonna call it separately just to test if this really works. Okay, and then I'll pass in the text. Oh, I think we need to use this double quotes here, and then what I can do is probably just call this inside the print function so that we get the output and print it out as well. And you can see that it was converted into uppercase, and this works great. And then what we can do specifically is we can just specify whether we really want it to be true or false. So if I just pass in upper equals false, oops, this should, yeah, this works. Okay, so you can see that all now the whole text was converted into lowercase, and even this capital T that I specifically added here is now also converted into lowercase. So this works, awesome. So now we know that it's working. We'll now move on to the next function, and I'll just go ahead and set everything back to normal. Yeah, okay. Now the second function that we want to implement is going to be so now we also want to be implementing. We want to implement the token. I think a good. I will not implement the clean text here. I will implement the tokenized text because I think this is actually, we've already covered this in our previous videos. So what I will be doing is I will just be creating a tokenizer using the word tokenize module in NLTK. And the way we will do that is first we will actually go ahead and initialize everything in the constructor, right? So yeah, so what I will do is I'll just go ahead and try to import. I think we already have imported everything from NLTK, so I'll just use that alias. Okay, that's good. Okay, so what I'll do is I'll just go ahead and go into my function here and create a variable called words, and here I'll just pass in my NLTK dot word underscore tokenize, and it already recognizes the function that we want to use. And here I'll just pass in the text that I'm receiving from the function as an argument, and then what I'll do is I'll just go ahead and say that the tokens that were separated out from this particular um, tokenizer, we want to be able to strip those words so that if there's any space, so what I'll just say is for word in words. First of all, this is a list comprehension syntax that I'm using here, which will go ahead and strip every word, and the way we do that is just call in the function, the built-in function in Python, which is word.strip, and it's going to remove any excess spaces from our string. Okay, that's essentially what we want to do. And finally, once we have done that, we can just go ahead and return the tokens, right? And I'll just say return tokens. Okay, that's good. So now we'll just save that, and now what I can do, I can just go ahead and create a separate file here. I'll just go ahead and call this one tn. Oops, I think this is not gonna work like this. So I'll just go ahead and say word. Yeah, so the function name, the name of the function was tokenize text, right? And then when I just run this now, let's see what happens. And you can see it actually separated out the words very smoothly, and this looks good. Awesome. Of course, we haven't actually expanded the contraction here. That's why we're getting the single quote between the N and T, which actually, this was able to intelligently figure out that it was a separate word. But we obviously need to expand the contractions to make our life easier. So that's what we're going to be doing. And the way we will be doing this is by using the function, by using the library that we have just installed, which is, this is actually too big. Okay, so this is contractions library that we have used, and I'll be using this library to actually fix all the contractions, right? And you'll see the magic it does. Okay, so what I'll do is I'll just go ahead and quickly implement that function as well. And the way you do that is you say return contractions dot, and the function we want to looking for is the fix function. This function actually receives a text, and it fixes any contractions in the string, and it actually goes ahead and updates the whole sentence and returns the sentence with all the expanded contractions. So let's just quickly test that out, and we're gonna just go ahead and run this one as well again, and then we're just going to run this, which is expand contractions, and let's see what happens. And you can see that so we had one contraction in our text, and you can see it was couldn't, so it was fixed to could not, and it's good. That means it's working, and we can now test it out with a little bit more complex string, such as could not have, which is 3 different words. So if I run this now, as you can see, it fixed this as well, and it says could not have, and you can see and you can realize the power of this little library, and it's how quickly it's able to just expand the contraction in our string. Obviously, we could have done this from scratch using NLTK, and that would have required us to actually create a big dictionary of all the contractions, and that approach is actually going to take a lot of time. So that's why I decided to use this library. Excuse me. So that's what I've done here. So yeah, so you can see that actually working right away. Now what I'll do is I'll just put everything back to normal, and then the second function that we want to implement is the stop words, which obviously which also seems very straightforward, which we want to be able to use the stop words corpus first of all, because let's understand what NLTK.stopwords does look like, right? Okay, so this gives us the error because we haven't implemented the normalized function yet. We've also not implemented a lot of functions yet, right? So that's why it's giving us errors. So don't worry about that. So yeah, so now what I will do is I will implement something called remove stop words. And what we want to be able to do is we want to be able to remove all the stop words from our text. And so now, in order to understand how do we remove stop words, let's first try to understand what really it means to remove stop words. So stop words are all those words in our sentence that do not really matter, right? For example, so if I write the box is the box is in the library, right? So you can see all these words right here do not really matter, and essentially when we're trying to train our machine learning models to recognize this text or classify this text, these words do not have a lot of a lot of significance in the sentence, and that's why it's important to remove them and make our sentence simpler and easy to actually convert this into a word vector, right? So, well, that's what we'll be doing in the future videos. But for now, all you need to know is that these words do not really matter, and that's why we essentially need this functionality to be able to remove stop words from a sentence, right? And that's what we're going to be doing. So obviously, the easiest approach would be to just create a dictionary of stop words and then just compare if we have any of the stop words that come into our sentence, just remove them, right? And a good thing is that we already have the dictionary available in our NLTK library. We have the data set for the stop words, and the way we actually create that, the way we call that is by using the NLTK dot stop the corpus dot stop words class. And the way we do that, first of all, what we'll do is inside this construct right here, I'll just say self dot stop words. And why I'm doing that is because I want to be able to access these stop words elsewhere in the functions, right? So then I'll just say NLTK dot corpus dot, and then I'll just call the stop words. And here, the last thing I want to pass in is the words, and then I can specify the languages. So if I'm working on English language right now, so I'll just use the English with the stop words from the English, and then I'll just go ahead and save this. And what we can do essentially is you can also try to actually see what it gave us, right? So what I'll do is I'll just say tn dot stop words, and then I'll just print this out to see what exactly do we get. It doesn't really give us anything. Okay, so I'll just go ahead and say, and you can see it gives us a list of all the stop words that we might have in our sentence. It also contains some of the contractions. So let's suppose if we were not creating this function right here, which is the remove stop words, and we wanted to just pass in our contraction and remove it. It also handles that as well. You can see it's a big list, and essentially we could just print out the length of this list as well. And it's going to give us, and you can see there are almost 179 stop words, and it's a pretty good start, because we can definitely use this to almost remove most of the stop words. And I think we would not find a lot of sentences that have stop words that are not familiar to this word, that are not present in this particular list. I'm pretty sure it covers most of the stop words in our English language. Okay, so what we will do is we will now implement the function, and the way we do that is we go into the stop words function, and what we will do is we will use the stop words that we've just created above. First of all, I want to be able to just separate the words that I get, and the way we do that is we just go ahead and use the word tokenize. But again, I want to be able to reuse this particular module right here because we already implemented the function. So what I'll do is I'll just call this one self.tokenize text. Okay, and then here I'll just pass in the text that I'm just receiving, and this function right here will return me back all the words separated out in a form of a list. And then what I can do essentially is I can just apply a token to check if a particular word is a stop word or it's a normal word, so that we can keep it or reject it, right? It's simple in simple words. So what I'll just do is I'll say filter underscore tokens equals, and then here I'll say token for token in tokens. Okay, this is actually a little complex to understand, but I'll actually explain to you. Don't worry about this. Now I'll say if the token is not inside the self dot stop words, that the list that we just created above, initialized, and then that's what we're checking. If this particular word is not inside this stop words list, then you don't need to return this, and you don't need to keep this in the list. And then finally, when you have the list, what we want to be able to do is we want to be able to finally join these all these words together in a form of a sentence, right? And then what I will do is I'll finally say text equals, and I'll just put a space here and say dot join, and here I'll just pass in what we call the filter tokens that we've created above. Okay, and filter underscore tokens, and finally I will return the text with the removed stop words. All right, so now hopefully this is going to work. So I will just test this one again. So what I'll do is, first of all, we already have the current let's just try this out with the contraction. So I'll just say remove stop words, right? And then just pass that out and see what happens. um Okay, so yeah, so you can see that it actually removed some of the stop words. First of all, you can see that we didn't got any change here. The word is actually there already, and we do have the quick as well, the fox as well. The couldn't was also not changed, and that's why you kind of get the idea that we really need to expand the contraction first before we remove the stop words, right? So that's why it's so that it's able to recognize that the could and not are two separate words, and then there are stop words to be removed, right? And that is exactly why I've written. So that's why I want to first of all tokenize my text and expand the contractions before I pass into the stop words, right? And that's why you can see that in the condition here, in the condition here, I'm first removing the stop words before I'm first expanding the contraction here, and then I'm removing the stop words in the right about here. And the reason why I'm doing that is because first of all, I want to be able to expand all the contractions so that it's able to process the string so that it's able to process the string very easily, right? And that's what I've done. Okay, so now what I will do is I'll just go ahead and give you a quick little hint. What I'll do is first of all, I'll just try to expand the contraction, right? And then I'll say tn dot expand contractions, and then whatever the output of that expand contractions is, I want to pass in this inside its stop words, and let's see what we get. Okay, and now you can see that this was actually able to remove the not, which also is a stop word, and that's why we were able to remove the not. And now you realize why I actually called the function remove sorry, the expand contractions before the remove stop words, because we want to be able to first of all expand all the contractions, and this actually works well. Okay, so I think we are good to go with our next function now, which is the remove special characters. Again, this right here can be done very easily with the help of some other very simple libraries that we'll be using in this particular video. Okay, so this one I will be using the import string. This library gives us all the punctuations and all the different type of special characters that we really need to remove, and we will use the same approach, the approach we used for removing the stop words, except we're just trying to traverse all whole string and seeing if there is any particular special character available, and we want to be able to remove that, right? And then that's why we need to match the pattern, and that's why you're using this regular expression library here, which matches the pattern for us, right? So that's the two libraries we really need to use for removing the special characters from our video, from our text. All right, so now what I'll do is I'll just go ahead and so now what I will do is I'll just say tokens equals, and then here I'll just pass in. Again, I want to be able to first of all separate out my text into individual words, and then the way we do that, we just call in the function again, which is the self.tokenize, right? And then tokenize text, and here I'll just pass in the text. It's gonna go ahead and return the words for me, and then what I should be able to do is, first of all, I want to create a pattern using the regular expression library that I've imported. And the way we do that is we say re.compile, and here I'm going to specify yeah, so I'll just say dot format. All right, and then here I want to say that re.escape, like all. So what we are doing is we want to escape. We want to be able to escape means you just want to remove or simply jump over all the special characters in our string and only keep the characters that are not special characters, right? And that's what we're trying to do here. Okay, and then what I'll just do is I'll just go ahead and get the list of all the punctuations inside our string dot punctuation collection, and then once we've done that, I think we're good to go. So now we will just use the same approach that we were using above, which is that first of all, I want to be able to filter the token, right? We have created this pattern. We want to now apply this pattern, right? And the way we apply this pattern is by using the filter function in Python. And so I'll just go ahead and say filtered underscore tokens. So we want to be able to create a separate token. separate tokens, where I'll say filter, which is the function in Python, and then I'll just pass in none here, and here pattern dot sub, and then I just want to say token. So what I'm doing is I'm just substituting literally nothing, right? So if you actually add a space here, it will so when what I'm trying to do is here, if there's a special character, I want to be able to replace it with nothing, right? Basically what I'm doing, so I could just replace it with a space, but that would not be a right thing, right? Because we will have some random spaces in our string, and we don't want to do that, and that's why I'm just removing it with nothing by just specifying literally nothing by just using the single quotes. And then what you should be able to do is you'll say for, so we are past, so now we want to get every single token inside our tokens right here. For token in tokens, so this is basically referencing this list is right, this list right here, you can see I'm using this list now. And then finally, once we have tokenized everything, we want to join together everything into a sentence back, right? So what we'll do is I will say filtered underscore text equals so I'll just go ahead and put a space again using the same parts that we used above, and then I'll just join together the filtered tokens, and then I'll just return the filtered text. All right, so I think we forgot to add this underscore here, and now we'll just run this now and see what happens. So let's try to actually test this out now, and we will just go ahead and test this out by specifying tn dot remove. I think we forgot to copy the text here, so I'll just copy this text again, Control C, and just say remove special characters chars, and yeah, so I think that's good. And now we'll just run this and see what happens. And yeah, so you can see it actually works. We only had one special character in our string, which was this single code right here, and it was able to remove that special character and replaced it with nothing, right? So that's working. That's good to see that's working. And also, so if I just try to actually add another special character like question mark, you'll see that it actually gets removed as well, which means it's working. Great. So I think it's working, and we can just try to actually try to test this by passing in a lot of different special characters like a comma, a question mark, and maybe even I don't know what else can we add. Maybe a dot like this. Let's see what happens. And you can see it removed all the special characters from our text, and it works awesome. So now we can actually go ahead and test it separately with the help of so we have we were able to test it separately, right? So what I will do is I will just move on to the next function now, and the next function that we want to implement is the lemmatized text and the stem text, right? We also want to I think we are also left with the clean text, which is just going to be receiving. So in future we will be creating text summarizers, and the approach that I will be following is I will be parsing HTML pages from the web, and that's why this function will be used there. So I will just go ahead and quickly implement this. Obviously you don't really need to know how do we parse HTML, because this is not really the scope of our course. We're just trying to implement it for the sake of our future projects, right? So I'll just go ahead and quickly implement this. That I'm using for implementing this is the BeautifulSoup, and this is a library specifically used for web scraping, and usually used for parsing documents, HTML documents. So what you can do is if you have a web page such as the one that I'm right now on, or if you have any other web page such as a Wikipedia page or something like that, what you can do is you can use this library to specify a particular tag, which would be a paragraph tag or an h1 tag, and then get the data or extract the data right from that page, and then get it back to your and then parse it. And this library can help you. This is actually a very powerful and one of the most used libraries when it comes to web scraping. So that's why I chose this library, because I think it will just make our life easier. Okay, so what I've done here is I've implemented this function right here, and you can see that what I've essentially done is I've just followed a very simple approach, where when we get a text, when we get the data from an HTML page, what we want to look for is are the text are the paragraph tags, right? So if you know HTML, you might have seen this tag right here, right? And most of the text that is present on web pages is on this is by using this p tag, right? So we want to be able to extract text from our, let's suppose, our Wikipedia page, and get all the paragraphs from our page, and then we will just go ahead and extract just the text inside the in that, and Beautiful Soup will actually do that for us, and we don't really have to apply any extra pre-processing or text pre-processing technique, or apply or an algorithm to parse the document. All of that is built in the Beautiful Soup, and it will just do that, right? So that's what we have done here, and then finally we'll just return the text, just as we have been doing with all the functions, right? So the only functions that are left that are left to implement is the lemmatized text and the stem text. But before we implement that, we need to first understand what lemmatized and stem text are.